Welcome back again. Now we're doing fraction addition. Here we have, remember the same thing that we do with our numbers, we don't add horizontally, we always add vertically. The same thing goes with fractions. We have 1/4 plus 2/4. So I'm going to take my fraction bar and I'm going to cut it into 4 equal pieces. And I'm going to start shading. I've got 1/4 plus 2/4. So I'm going to do that in a different color. And I'm just going to add on 1, 2. Okay? So here our denominator stays the same, which is 4, and we have 1/4 plus 1/4 plus 1/4 is 3/4. Okay? Let's take a look at B. We've got a whole number, 1 and 3/8. That's called a mixed number. So we have one whole, so I'm going to shade it in, 3/8, 1, 2, 3. How can I make sure it's 3/8? It's 1, 2, 3, 4, 5, 6, 7, 8 equal pieces. Now we have 2/8. I'm going to shade that in. I'm just going to connect. It makes it a lot easier to visualize the connection or the addition. So again, we have our denominator the same. Let's look at our pictorial model. We have 1 and 1/8, 2/8, 3/8, 4/8, 5/8. So let's make sure our numbers keep our denominator. What is 3 plus 2? 5. We have one whole and no wholes, so that gives us our 1. Okay, let's take a look at E. Let's move over to E. We've got 1 and 5/12. So 1 whole and 5/12. 1, 2, 3, 4, 5. Here I have 1 and 9/12. So I'm going to do my 1 whole. But watch what I do with my 9/12. I'm going to continue shading up here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 12. See that again? 1 whole and 9/12. 1, 2, 3, 4, 5, 6, 7, 8, 9. Looking at our pictorial model, how many wholes do we have? 1, 2, 3, and 2 12ths. 3 and 2 12ths with our pictorial model. Let's look at our numbers and see how that works. Our denominator has to stay the same, so we have 12. Now we have 9 plus 5, 9, 10, 11, 12, 13, 14. 14 12ths. Okay? It's kind of like when you're adding 1s and 10s, right? So now we have our whole numbers. 1 plus 1 is 2. This is called an improper fraction. We can't have a mixed number and an improper fraction in one fraction. So we have to simplify this. We have to carry 2 of those over. Why? How many 12ths equals 1 whole? 12 12ths, right? So if 12 12ths, we're going to take away, so you're actually subtracting at the same time. If we take 12 away, you're going to be left with 2 12ths. I have this 1 whole hanging out in the sky somewhere. Where is it going to go? Over here to my whole place value. What's 1 plus 2? 3. Does that make sense? I took 12 12ths away, and I added it to my whole number. Because here's your one whole and your one whole from this group and this group. But then when you added 9 and 5, you filled up another 12. That's the one whole that you're carrying over to the wholes place. Okay? And let's do let's see. Let's look at I. An artist mixed 1/4 pint of blue paint with 2/4 pint of red paint. That one should be a good one for you to do. I don't want to do that one because we've already done another one. Oh, let's take a look at this one. J, which expression is equivalent? What does equivalent mean? Equal. 5/4. Some of us say, oh, that's got a 5, that's got a 4. Those are 5s. They're all there, yes. But what does this mean? Can we add fractions with different denominators? Is that what we're focused on in 4th grade? No. Let's look at B. 1/4 plus 1/4 plus 1/4 plus 1/4 plus 1/4 would equal 1, 2, 3, 4, 5. And our denominator has to what? Stay the same. Let's look at C. Our denominator stays the same. And we have 1, 2, 3, 4/5. Is that the same? No. Here we have two different denominators again. That is not a 4th grade TEK. That's something they do in 5th. Okay? You compare with different denominators, but we don't add and subtract them in 4th. Alrighty, you'll learn that next year. Thank you very much.